What is going on, guys? It is Bucky, and welcome to your, this is a third intermediate Java program tutorial. And in this tutorial I'm going to be going over a concept called recursion. Now, recursion is usually a concept that gives a lot of people trouble because, in concept it's kind of confusing, but it's actually really simple once you see it in action. And that's what I'm going to be teaching you guys today. Now, all recursion is it's pretty much a method that calls itself. So here's what we're going to be figuring out in this tutorial. Let me go ahead and give myself space. In case you didn't know what factorials are, like 5 factorial in math, it pretty much means 5 times 4 times 3 times 2 times 1. It pretty much means whatever number you tell me to give a factorial times itself by all the other numbers until 1. And obviously you don't times it by 0, because then anything factorial would be 0. So 5 factorial is 120 if you times all those together, equals 120. 4 factorial is 4 times 3 times 2 times 1, which is 24. 3 factorial is 3 times 2 times 1 if you want, which is 6. And 2 factorial is 2 times 1, which is 2, on and on. You don't need to hear me do all that, but you know, I just said it anyways. But anyways, let's go ahead and write a method displaying what recursion is. So as I said, and as you can see, I probably should say this, I'm outside my main method right here. So here's my main, and I'm making a new method right here, and I'm going to name it public static long, and I'm going to name it fact, and it's going to take a number as its parameter. So as you can see, why a method calling itself would be useful in this case, because you don't really know what number they're going to enter to begin with. So say you were expecting them to enter 5 factorial. Well, you can just say, alright, take that number times 4 times 3 times 2 times 1. This would be good in this case, but if they entered any other number by that, we can't really prepare for what number they enter, so we can't give it a set of numbers to multiply itself by. So this is why we need to use something called recursion. Now, in case you guys didn't know, if you do 0 factorial or 1 factorial, the answer is always 1. So let's go ahead and prepare ourselves for that. And let's go ahead and make if statement. If they enter a number, if their n is less than or equal to 1, which is either 0 or 1, what do you want to do? Well, all we want to do is return 1. Easy enough. Take care of the easy things first. And now let's get into recursion finally. Else, what do we want to do? Well, we know factorial is pretty much that number that they gave us times the number below it. So, for example, if they give us an 18, it would be that number times 17, and on, 16, 15, 14. So, else, what do we want to return? We want to return that number times the same function, fact, but we want to change it, the number of it. So here's what would happen. If they gave us a 0, 1, we're just going to return 1 as our answer. They're going to be happy. But if we gave them an 8, then it's going to return that 8 times 7. And it's going to call this method itself. So check this out. This method is called fact, and the method we called inside it is the exact same method. So what it's going to do is this. If you gave it like 5 to begin with, it's going to say, alright, I'm done with this. This isn't 1, so let's just go to this. Return 5 times 4 of this method. So it's going to pass 4 into this method. And now this method is going to have 4 in it. So it's going to return all this, skip all this, go, alright, for this one I'm going to return 4 times 3 factorial. Alright, keep going. I'm going to return 3 times 2 factorial. Call this method again, return 2 times 1 factorial, and finally when we get to 1, it's going to say, alright, I finally have a number to return instead of returning your dang method again and again. So I'll show you guys later visually what it does, and let me go ahead and run this one time. So system out print line, and let me just go ahead and do like the factorial for 5 or something, just so you guys can see that this actually works and I'm not just BSing you. This is 120 right here. So again, what it did is we passed 5 in here. It wasn't any of this, so what it did is it returned 5 times 4 factorial. So it pretty much took this, when it got here, it called itself with a different parameter. So then it was 4 times 3 factorial, and it kept calling itself and itself until it got to 1, and then once it got to 1, it could fill in all the blanks in it it pretty much solved the puzzle. And let me show you guys visually. This might be a little easier. So at first we call it 5 factorial. Alright, so what our method did is it called 5 right here, return n, times factorial n minus 1. So 5 times 4 factorial. And it doesn't have the result for this yet. This is the result we're trying to achieve eventually, but it doesn't have the result for this yet. It needs to fill it in later. It says no problem. Well, now I'm just going to call a new method to try to solve this, called 4 times 3 factorial, which is 4 minus 1. Oops. Which is 3 factorial. Well, now I need a result for 3 factorial, so I'm going to do 3 times 2 factorial. Well, now I need a result for 2 factorial. So now what I'm going to do is 2 times 1 factorial. Well, now I need a result for 1 factorial. Oh, well, look at what we have here. This is called the base case. And whenever I get to 1, I can just return a 1 eventually. So it says, alright, 1 factorial equals 1. Yeah, baby. Now we have the answer of 1. Now we can begin filling in the blocks that all of this, by the way, is stored in memory. So now that we finally found a real answer and don't have to call myself again, we can begin filling in all the blocks for all of this. So let me go ahead and change this. And it says, alright, 2 times 1 is 2. Problem solved. Out of the way. 3 times 2 factorial, well, since we know this is 2, so this is 3 times 2, which is 6 factorial. 4 times 3 factorial is 24. Or wait a minute, I may be wrong. 4 times, yeah, that's 24. Bam, problem solved. This one. And now that we know what 4 factorial is, it's 5 times 24, which is 120, right there. And oh, you asked for 5 factorial? Yeah, it's 120. So what it's pretty much doing here is it's trying to solve itself, but it's storing what it doesn't know in memory, and then when it finally finds a number that it can work with, it tracks through all of the numbers again and steps its way back up until it can finally solve its answer or its problem. So I know it kind of sounds confusing, but I mean, this is the easiest way I can explain it. Pretty much calling a method, pretty much calling itself until it gets to a base case, which is in this case 1, and then when it finally gets that number, it can stop calling itself and start solving this problem. So again, don't forget to add a base case, because again, if you don't have a base case, it's going to just keep going and going like an infinite loop, and it'll just never end. So that is your quick tutorial on recursion. If I made this confusing, then leave me a comment and know, but I want to know if I taught it right or not, because I mean, it's a really simple concept. All it is a method that calls itself until it gets to a base case, and then when it does, it can solve the problem. So thank you guys for watching. Let me know what you thought of this tutorial, because I'm interested to hear. So thank you, don't forget to subscribe, and I'll see you next time.